as usually. So we start with the recording. Stream. Okay, let's start it. Now the input is there. So yeah, basically what the delegates are. So delegate is actually the way how we can consider, say, the methods as the real objects. Yeah, so this not as the real objects. We can store them as part of real objects. This is, I would say, maybe a little bit of a functional approach, what is mostly used in JavaScript, because in JavaScript, almost everything is based on the functions, and the functions are used as the objects there by default, and everything is based this way. And actually, yeah, when we talk about delegates and events, I would say this is a little bit specifically mostly used in JavaScript. Yeah, so I mean, it's of course also used in C#, but the concept of events and delegates and using functions as the objects, this is very heavily used in JavaScript, in web programming. So if you work with, also not only web programming, I'll say actually, maybe first before start a little bit of motivation. Why do we actually need this, and where do we need delegates and events? Mostly, I'll say events. They are needed in the applications where we need to press something, touch something. Application and websites, because again, for example, on the website you have the buttons, let's say, and if you press on the button, then some action happens. And this action is actually, it's always some kind of logic, some kind of code which is triggered on the event. Like you press the button, there's the events triggered. So, and technically it works in the way that this event is registered, it is assigned to the button, so the program knows that when you press on the button, then the corresponding event is triggered. Generally, when we talk about the objects, then in the context of, if we talk about the websites, then it is mostly done by JavaScript or some related JavaScript frameworks. And so in C# in the context of .NET, it is also mostly used in the applications, in the like if it's a mobile phone application or just any other application of .NET, then of course we use C# and such things. But let's then talk one by one. First, we start with the delegate. So this is, as it stands from the name, it means that we can, as you can see here, we use some kind of polymorphism, we can call it this way, that one function, one exact, let's say a variable, or most often say variable, can store and can store multiple different methods. So in this case, we have such kind of polymorphism here. And we all know that the object contains the list of methods. And basically we can invoke this list. And when the delegate is invoked, it calls each method in the list it has. It wasn't talk on that one. So first of all, how do we define and use delegate? So first of all, we declare delegates inside the class, and that is derived from the system delegate class. We instantiate it, so it delegate instance it multiple join. So it encapsulates an invocation list, so it blocks everything inside, and then each of these is referred to as callable entity. And at the end, we involve this. So it's so we have the instance of delegates at this point, and then we of course pass the arguments and call the methods this way. So how do we declare the delegates? I would say similar way as the variables or other functions, more similar as we do as we do for the abstract methods. So for the abstract methods, you know that we don't have the implementation of the function. So here it is also done in a similar way. We don't have the implementation. We have the, as usual, access modifier. Then we have the returning type. It can also be void. And then the name of the delegate. So the same as for the methods and the variables. And the arguments, the signature, method signature, what we want to pass to this particular delegate. So really similar to what we have in the past. And so then it's quite similar to what we have in the past. And so at the end, when we want to create a delegate, then we pass the function. So maybe let's directly start with the schema, so you can follow not only the presentation, so you can also check the code. So today is the 9th of December already. Okay. So that's what tasks I will add cards as usually I do, so we can put everything inside. Oh, okay, this new version of why is it done this way? Okay, it's strange a little bit. Okay, maybe I need to configure my watch. But yeah, by the way, for those who has not visited the session, yesterday I installed a new version of Visual Studio yesterday, and it looks like I need to configure it a little bit. So maybe some things will not work will not be set up as before, but then if I have time, I will manage these settings. But it has some cool features. Not sure if the previous version of the Visual Studio allowed, but it's much more easy to type the things here. So you see, if you type and you can press tab, and then it directly writes the suggestion. And suggestions are really useful. We found this yesterday. I'm not sure if the previous version had this opportunity, had this option, had this feature. So if you know, then please comment. But yeah, this version definitely has it, and it looks very easy to to write the code this way, much more easier. Okay, so then let's continue with the delegates. So I create public delegates, maybe not void main, but let's say I have the function, for example, the function add. So let's say that would be, oh no, maybe not add. Let's say print value. Void. Print value. So in this case, I can pass maybe the value. So we have the delegate at this point. I'm missing the don't miss sorry, yeah, sorry, my fault. Moments. I'm not sure if I can do it set up. Yeah, I'm not sure if I can do it set static methods. So yeah, normally we don't do it under the static methods, so let's yeah, they should be part of the class normally. Okay, so this is done, and yeah, let's say we have the function. So we have the public, you know, then we will create the object, because delegates are not, at least I never actually seen that they used as the statics. Yeah, mostly and I think they can be used as statics, yeah, because mostly we deal with them as with the real variables, with the real objects, and for these cases, we need to use the objects. Yeah, that's why maybe we'll not deal with them as the statics. So yeah, then I create the right. Let's say I can write any void, yeah, any method which has similar signature. So that would be, let's say, welcome message. This would be string value. And here it's not the value, but it's maybe a local message that be the user, for example. And then I say welcome. And then of course not the value, but the user in this case. So I have just a simple method, and I have the delegate. So yeah, maybe I will then create a method. Let's say that will be the method run. I'll use. So this will be similar to main, but this is non-static, so it means that I can create the program. So I create the program as the object, and I can call the method run. Yeah, so basically this will be the option if you need to use their instance methods, instance variables, then you usually see that we have some kind of execute methods, execute run, or something similar. Yeah, okay, so and then let's say I do it here. So what do? I create delegate print value. So that would be let's see, welcome user. So what can I do? I can pass the void this way. So that would be, say, local message. Or as I can make it easier, I mean not easier, but more simple, I can assign the value, but the method this way. Actually, there's no difference if I declare it this way. If I do it this way, or if I do it this way, there's no difference. It's just a shorter syntax. Yeah, so this is one option, and another option would be even more simple. Like in this case, yeah, what I have a separate method declared somewhere. Then I pass this method to the variable. In addition, I can also, as an alternative, I can also maybe not write this method, but what can I simply do? I can use the that should be, I guess that should be string. No, hold on. Oh, I guess that will be fine. Then I have user, pass it, and then that would be console right line, welcome, and the username. So this would be even like more direct way. I don't need to create the method somewhere else. Yeah, basically this is, we'll say, the same as this, but just a shorter syntax. We don't need to declare it separate. We just can simply provide the values there. So, and if I run, I can, let's say, I call the method local user. Let's say that would be pt, something like this. Maybe username. Okay, so let's run and see the results. This one. Run the program. Yeah, so and we see that the program is executed. Yeah. So yeah, this is the thing, and the thing is that so what's the advantage of this? The fact is that print value can be any method. So in this case, I have the option that the print value is let's say what we have here. But let's say I have more complicated logic. I have the method which uses another method, and the fact is that in some cases I do not know which logic exactly needs to be executed. So in this case I can simply provide the information to the method. So let's say I have the method void, let's say do something. At this point maybe I will not imagine some useful logic, but the thing is that this method does something and prints the value. So it simply means that I can print the value. So I call this method print value, and say the text, yeah, some text. I mean, in general, this text can be calculated somewhere, but at this point I just simply put it as is. So yeah, and the thing is that I can call this method, and instead of, so let's just comment out, and instead of calling this method, instead of just writing some if cases or something similar, I can directly pass the method as the variable. Okay. So the result will be similar, yeah. So it will just simply say welcome to text. But the thing is that, okay, let's say here I have this text, then let's say I create another method, which would be wish you Happy New Year or Merry Christmas. So then this would be maybe again user or somewhere else. Let's say maybe name, and can write wine. Some more complicated logic that would be Happy New Year. Yeah, so this is just random text. Yeah. In general, you can find maybe something more interesting. But yeah, the thing is that I call the same method, but I pass now different function. Yeah, and in this particular case, there I call the same method. Hold on. So what's wrong here? Oh yeah. Okay, this is the disadvantage of this Visual Studio, because I mix up if it is the suggestion or the actual value. Yeah, so you see here I call, in this case I call the same method, do something, but it actually has two different methods. We'll later on see how we in what cases we can use, but at this point you see what we can do, and this is the thing that we can use the function, we can transport the function as the object. So again, it means that I can transport it in between different objects, different methods of the application I have. Yes, so in this case, I simply pass them to the method, but let's say we have maybe even another object, yeah, and another class. So I use these methods, I pass the logic of these methods to another class, and then these methods are executed there. Yeah. So yeah, at this point, we should understand that the methods this way can be used as the variables. Yeah, as the variables. So we can move them between the places. But yeah, later on we see more relevant examples to see where it is used. But at this point, do you have any questions? Okay. Okay. So yeah, so delegates does not know or care about the classes of the methods. Yeah, the method can be, yeah, it can be a static method. Yeah, that's also true, but again, at this point, so in this case, let's say this is, yeah, I can't, yeah, I mean, this can also be a static method. So let's say print value, say delegate, and I assign them a message. Okay, delegate. Yeah, so it can also be static. So at this point, it's just the program code. So delegate does not care, but I mean, for the delegate itself, I mean, yeah, it can also be inside the static methods, but again, we'll mostly work with the objects, and I'll explain you later on why. So yeah. Okay, and yeah, so here's the similar example. I have the function. The function is passed to the delegates. Again, if you want, you can use new the name of the delegate. If you want, you can also keep using this. It's not mandatory. It's up to you what's better. And in addition, we can call not call, but we can declare the function directly, as I shown here. We can transform the expression and call declare the function directly. Okay. So yeah. So here's again the example. I declare my delegate. I create different delegates. So again, delegate there is one type, but one type may actually store different methods. So this is the advantage of this method of this approach, and we see that we can pass static function. We can pass we can pass static function both full. Then we can pass static function from another class. Yeah, by the way, it's not only that I can access the function from this class, I can also create another class. Let's say that would be another class. And so let's say I have the method here. So public string, and I write the void. Just hello something. Okay. Just some random text here. So, and yeah, so in this case, what we create delegate. Delegate. Create void print say value. Yeah, so by the way, I can also Oh no, I can't. Yeah, okay, I can't overload them. I can't overload them. So this is the disadvantage of them, but if I simple right print, then say I create another delegate here, and I use another class, and okay, I need to declare the static here, because if it's not static, it will not be accessible here. Well, hello, no, not this one. Sorry, hello, not this one. Because if it's not static, then it's not accessible. Yeah, so the same way as we access the static functions, static methods inside the code, so the same way we can get the method to pass it to the delegate variable. So this is this example. Okay. So yeah, and then also for the instance method, we need to have the object. Okay, so we see that here, if I declare the method as static, I can access it directly from the class. If I don't create it as a static, I need to have the object to be able to access it. So it means that I create another class object. So I create the object first. And then I can access the method directly from the object. Yeah, so if we have the object, then we can access the instance. So remember again, instance variables and instance members belong to the object, and static members belong to the class. And that's why, same as always, and same as everywhere, if we access the instance methods, then we need to access them from the object. If we access the static methods, then we can access them directly from the class. So the same is here. Right, so do you have any questions about this? Okay, move on. So in this case, all these three methods, they do the same. They simply return the value true. So, and as an option, we can use the lambda expression, the anonymous method. So it means that we can create a delegate and then assign the function to this delegate. Okay, so again, lambda expression works in the way that we have the variable, we pass the variable to the function. So at first we have variables here. So here we have one variable. In theory, we can have multiple variables. So let's say void. And yeah, by the way, if the void is private, not public, it will not be accessible it should not be accessible from outside the object. So the same rules as for the other, the same rules for the access modifiers. Private protected are more restricted than public elements, public methods and attributes. Yeah. So, and yeah, let's say we have two arguments and we want to use the lambda expressions. So create maybe delegate here. Create voids. let's say so let's say some, maybe, yeah, maybe let it be some, and so let's say I have, yeah, maybe in general I can say we have two objects, object 1 and object 2, and okay, this may be a little bit more complicated case, but maybe more real. And then I create a new, so we have some, let's say some integers. Let's start with simple, and here I have two arguments. I have x, y, and oh yeah, and of course I can have the returning type as well. So the returning will also be the object. At this point, this may be a little bit more complicated case, but plus y. Yeah, at this point, since I have a little bit complicated case, I need to cast the casting here. But yeah, it still works. So let's, yeah, in this case I used the object, not the integer. So that was because again for, yeah, maybe let's I'll show why. So and let's say I can call this method. Say I have some integer, and that would be, say I print some integer, say something like this. I print, oh no, it's simple print something. And no, so it's not print. Just simply write them. Yeah, by the way, we can also declare, for example, that we want to, instead of using console write line, I can use the delegate here. So I have delegate. Let's say, okay, let me use them also. Yeah, so say print some print text maybe simply, and then I pass the argument here, and then what I do, I can directly assign the write line. It's not. Oh, oh yeah, of course I need to have the variable. Yeah, sorry. I declare and yeah, of course I need to define if it's the void. Yeah, and here I can then say it will be print and maybe print text, of course, print text, and then I can delegate write line. So in this case, it means that I can, instead of calling console write line, I can simply call print. And here I need to cast some to string. So in this case, yeah, by the way, I can do it directly here. I can also call return from here. Oh, no, maybe a moment. Okay, maybe just instead of return, I can, it will understand. And And then the thing is that I need to turn this to string as well. So then this may look this way, but yeah, the thing is what happens here. I sum two integers, so the returning type of the sum of two integers is integer, and then so this is the integer, and I pass it to, sorry, not I pass it, but now this is the integer value to all value itself, and I call to string. I can call, of course, to string from the integer value. It will then print me string, and then I can simply print this value. Oh no, hold on. The returning type is still the object. Okay, then so then I better do it this way. Or no, hold on. Sorry. I can. No, let's make it more flexible. I'll then call it the string from here, because this will be more flexible. Okay. Okay. So let's see the results. Yeah. So the result is printed correctly. Yeah, so, but yeah, I can pass multiple arguments and I can return the value from the method. So in this case, you see that I use integers, but let's say I want to sum not integers, but say some strings. So in this case, again, I use xy, and then I use this. Yeah, so again, I need to cast to string the object. So let it be x plus y. So in this case, I can also print the values, and then let's say that would be text part 1, and that would be text part 2. And of course I need to convert it to string. So what's the point here? Oh no, it's fine. It is fine. Let's print this. This should work. Yeah, so again, in this case we delegate one function into another. In this case we have, I'll say, quite a simple logic, but I mean, in practice this may be a bit more complicated, especially if we not write the lambda expressions. Yeah, because lambda expressions are mostly used for the small actions like these actions, and they're quite small. But if we have some complicated logic, then of course it's much more better to write the separate method and write all the logic here, because otherwise if you simply type the expression logic in the several lines here, then of course it will be quite messy, I'll say. So do you have any questions about this?
Yes,
Yeah.
I have a question. I believe you somehow mentioned it already, but what would you say is the main advantage of this delegate method?
I mean,
advantage?
the advantage of delegate method is that we use the methods as the variables, the object. So it means that we can pass the method to one place or into another place. So I've shown some small example here. So we can simply pass the method to the, sorry, not the method, but we can pass the method delegate to the function. Yes, so in this case, I say, here is the method. Again, in this case, it's a simple method, which does just simply one thing, but let's say we have a large method, which may do several things with the branching and all the other stuff, and then we can simply say that for this method, please take the function, please take delegate, then this will simply be the code which will be then used, which can be then used inside this method, or it can also maybe passed further to other methods. So then simply we move the method here. So we take the delegate, we take the function, and we pass it from one place into another, and then it can be called in different places in the program. Yeah, so basically the main idea is to use the function as the object, which then can be passed to another place. We later on see that it can be used as a part of the events. We will talk about the events a little bit later, but so the key part is we have, let's say, the piece of code which can be then moved around the program. Yeah. So this is the advantage of usages.
Thank you.
Yeah. So yeah, we take this and we can basically the same as the variables. You can place the variables in. You can put the variables into the different methods. You can pass the values from one method to another. The same is now for the functions. Again, on practice, it's not needed everywhere. It's not. I would say it's not really the basic of programming. However, I would say the methods, the events are used quite frequently in programming in different areas of programming. But these are, I would say, more specific cases. But we will discuss them. Okay, so yeah, this was about the lambda expressions. Again, lambda expressions are the same functions, but they can be written in the shorter way, usually in one line or something similar. And you'll see that it is quite rarely done for the lambda expressions if there is more than one statement. Yeah. Because yes, in theory, I'm not sure if I put it here. So, for example, I'm not sure if I think I cannot really do it here. Oh no, I think I can do it. I can do it. So maybe in this case I will not show this as. Okay, it's not acceptable here. Yeah. Okay, then in this case we cannot really do this. Okay. Yeah, because usually okay, maybe I can maybe find some examples, because it's possible for lambda expression that you pass the value from one method into another method. Yeah, so basically, maybe find some examples. In a moment, I can quickly. Yeah, I just realized this maybe. Yeah, usually you see there is this operation, but some practice. One moment. Yeah, especially in C#, I'm not really sure. One moment. Yeah, maybe in C# I haven't seen this. I think I've seen this in other languages. One moment. Okay, maybe at this point I will not find the example. Okay, yeah, but my idea was that simply we can we can have multiple method processes. So we pass the arguments from here to here. Then in theory we can also pass the arguments from one method into another, then from another method into another method, and so on. So we can create this chain. I do not remember the example when did I have it, but I remember something similar. And it is, I would say, this may be the advantage of lambda expressions, that we can simplify the text. But okay, maybe this. Let's talk maybe later about this. So yeah, for now, the main thing is that from the expression is say quite small method. Yeah, and yeah. So yeah, instead of formed expressions, you can directly use the oh yeah, instead of I guess that would be the same if you instead of formed expression you use basically use delegate and then delegate, and I think then we can let's create another method, another delegate. So let's say I create something, let's say double, then I call it as the delegate. So not delete, but delegate. Then I pass double and x double y. Okay, I think maybe this will not work, but and then I return x plus y. Yeah, in this case, this will not really work. Okay, I also need to run. So because I can, I need to then use the object here, the object here, the object here. Hold on a moment. So just a quick check. Why did I have a space here? Yeah, of course we cannot use double. We need to match the signature. Yeah? So this is going to be a little bit disturbing, and we need to match the signature. Here we have object and object, so it means that we also need to have the object here. Yeah, and then only after that I can change to double. Okay, so now this will. Yeah, so basically this would be the same as, yeah, right? Same as, right, if I basically do the same approach here, yeah. So as you can understand that. So these two are the same. Okay, so let's move on. And yeah, so this is how we provide lambda or anonymous method. So these are the same. Actually, there is no difference. So we'll just see this example. So again, instead of found expression, I use delegate. So this is more standard looking code. And so see that this is simply standard looking code as we usually write, with the brackets, opening brackets, closing brackets, and method signature, parameters, the types of the parameters, and then the object. Yeah, so maybe for you that's maybe a little bit confusing. Why do I use object here? And the thing is that I want to use the signature, which is common for many different types. So it can be common for basically all the objects. Yeah, because again, if I want to use the same signature for integers, strings, doubles, also other objects, all the other objects, so the only common type for them is object. Yeah, remember, object is the superclass for all the objects in C#. That's what means that every variable, every class I use, they all inherit from object, and that's why I can always store, yeah, I can always store any value under the object variable defined as object. Yes, so under the object variable I can store integer, strings, all the types we have in all the possible types we have in C#. I can I can I can store under the object, and I guess I cannot store delegate as the object, but let's quickly check. I haven't checked this before. Say my option, something like this. So I think I cannot store the delegate, right? Or I can. Oh, yeah, I also can. Yeah, actually, we can also store the delegates under the objects. Yeah, so basically, object. Yeah, because delegate itself is it's the system delegate class, and yeah. So by the way, we can also store delegates under the objects. So in fact, object can store everything. Object can store everything, and this is why it's the most, let's say, the most flexible type. It can accept everything, and we can use it as everything. Okay, so do we have any questions? Okay, no questions. We move on. Yeah, so here is the example. Let's analyze it a little bit. So we have the delegate. Yeah, add the delegate, so it accepts integer a and integer b. I mean, in this case, the names of the variables are not really important, as usually. So then, yeah, here I can pass multiple methods to the delegate. Yeah, so I can basically use one object function as the method for the sum or for the multiplication. So this can simply use both. So in this particular case, so let's create another example. So I say public delegate maybe so just again more general I can use object. So let's say add multiply, and here I can again use two objects. So again, because I can use this also, again, we can't really multiply integers, sorry, not integers, but strings, but in this particular case, yeah, so last example, let's maybe create here, I can say multiply, say I add, and here I will, let's say xy, and I say I multiply doubles, x multiplied by y. Oh, sorry, that will be multiply doubles. So in this particular case, I can also say add doubles, and let's say sum doubles, and this would be pretty much the same. And here I sum them, and then let's say I have the function with do action, let's say double. Let's say do double action, maybe something like this. So here I have add multiply, I pass the variable. So this will be used now as the variable. So this will be the place, the variable which will take the function. And then I have two doubles. So let's say double A and double B. Okay, and let's say here I have two double action, get double result. So here I return and multiply, and then AB. And of course others I can, okay, I need to cast double. Yeah, by the way, I can already cast it here. Oh, yeah, by the way, again, I do not understand. Okay, then I need to cast it here. I use the casting because by default it is defined as, not by default, but it is defined as object. Yeah, so see and multiply, I defined it as object, so it means that the returning type will be object. So it means that I need to do the downcasting. So it means that I need to convert the object to object type to the actual type. And in this case, I know that this would be the double. Yeah. Also, in addition, I can check if so I can check, for example, if add multiply, say AB is double, and then I can return double. Otherwise, else I return, let's say -1 or something like that, or 0. Yeah, so and in this case, you see, I do the action, but the inside this function, I don't know what the action would be. The action is the sum, or so if we add, so if we sum two doubles, or we multiply them, or we do some other action, yeah, so we can also create the action divides doubles. So the same way here, divide doubles, so that would be, I need to cast them again, double x divided by double y. Yeah. So in this particular case, I can pass any possible add multiply delegate here. And this program does not know, yeah, so if, I mean, this program does not know what will it take. Will it take the sum, or the division, or multiplication? So it depends on this variable, which will be then provided from another place, right? So, and then this logic will be executed here. So do you have any questions? This. Okay, so if not, then maybe let's have 10 minutes break, and then we meet at 7:40. Okay. Okay, I'm back. Let's continue. Let's continue. Yeah. So in this particular case, this is what I said. Delegate may have two possible, not two possible in this case, particular case. We have two possible, but in theory, you can have as many possible functions assigned as we want. So this is this is done here, and by the way, I can also make some branching here. For example, I have, let's say, okay, let's do this. So, for example, I have, let's say, sum. So let's say that will be private. Think. Okay, let me void show sum. So this will be just for me, and then yeah. So here I'll provide, let's say, two objects, and then let's say if, for example, if so let's first declare, say, the sum, sum object, and then I can, let's say, I check if A is let's say we have an integer, sorry, and P is, say, integer, then sum equals, we have some integer. This is for a public void run a 2. One moment, let me think. Okay, let's then declare them as static functions, because I need this. One moment. Or maybe I will copy paste these, just that easier at this point. I mean, of course, in practice we need to find a common place, but in this particular example, let's maybe use them as they are. So for example, so let's imagine they're located somewhere. Oh yeah, I mean, we can also, okay, I guess that would be a good point. If we locate them, we can also locate them on the top of the class. Define them as private, but they can also be, of course, they can also be the members of the classes. So in this case, I don't need this location. Yeah, again, remember we have like if we declare the variable with the same name as the class member, then these variables will be used. If we don't use this keyword, yeah, because like I can have the variable, I can also have this variable. This will then access this particular member. If I don't use this, then it will access this particular member. So I mean, the same as for the basics. In this case, maybe I'll skip declaring them here, since we don't need them here, since I already declared them here. And at this point, yeah. Then in this point, I can already pass one of these delegate, so that would be some integer, else if, let's say, a is double and b is double, then let's say the sum is sum double. Excuse me. And then let's say also if they are strings, so let's say if a is string and b is string, then the sum would be excuse me. And I'll use this keyword because let's say this will be more precise. And then for string, this would be this sum string str. Yeah, so in this case, I use the branching to find out the which function I want to use. And then I use this function as the variable, and then I can simply, let's say, private void display sorry. Oh no, sorry, I'll not use display here. Now then simply first I check if sum not equals null, because it can be null. So if sum equals null, maybe then I return. Let's assign null as the default value. Yeah. So in this case means that it has no object assigned. Yeah. So and if it's not null, it means that there is function assigned. So I can show the sum. So let's say I write, and then I say sum, and then I sum two objects. At this point, of console write one, I don't need to call to string directly. Yeah, so again, at this point, when this method is called, the program does not see which type these two variables belong to. And so they can be integers, they can be doubles, they can be strings, and excuse me, it's also a little bit cold today. Windy. That's why I need to got a little bit cold. Okay, but no problem. And yeah, so at this point, again, the program does not see what is the type, so it means that it can get it can use some branching here to determine the right method to call. Okay, so do you have any questions? If not, then we can proceed further. So yeah, then we can also have such covariance and contravariance. So in this particular case, yeah, in this particular case we have the returning type base. So again, remember we have delegate, and the delegate shows the returning type. Yes, in this case, the returning type would be base. Yeah, so again, the returning type can also be any type in the query. So it can also be the class. Yeah, because the classes are also the types. Remember this, yeah. So then yeah, and the class itself can also be the variable type as class can also be returned. So yeah, can also be returned. So yeah, in this particular case, say we declared one method which returns null and another method which returns null, but they both return the subclasses of the class, the objects count as the subclasses of the class base. And then we can assign, yeah, we can simply use the casting here. So it means that, so we see that delegate itself is declared as covariance delegate. It returns the base class, yeah, but we then pass the methods which return the subclass, one of the subclasses of this base class. So simply here we have the situation when we use the upcasting. Yeah, upcasting is used here as well. So it means that I can declare the method which takes the superclass as the returning type, and then we assign the method with other types. Yeah, so simple example would be that I have say the class, let's say my superclass, and then it doesn't matter what is the logic where, let's say then my subclass 1, that would be subclass 1, which extends the superclass, my superclass, and then in my another subclass, which extends my superclass. Okay. So the thing is that I can declare the delegate, let's say delegate, let's say it returns my superclass, or hold on, name of the delegates, delegate, oh yeah, of course, let's declare it under the, let's say it has this private delegate. And again, access modifiers, we can define them. Yeah, so from where the delegate is available. Not. So let's say we have my superclass here, and then the name of the delegate. So let's say my delegate maybe. And so on. At this point, again, what's the point here is I can, so yeah, let's say I have the method which, yeah, so maybe I can also simply do the following thing. I can say my delegate, let me get, so get subclass 1, so subclass 1 object. So in this particular case, I can, so we can say we have no arguments to pass, and then I return new my subclass. Oh yeah, I don't need to pass return, it will automatically understand. Yeah, and then same for class. Subclass 2 object. So this will be new my subclass 2. And yeah, of course, I can also return the class itself, so that would be get my class. So in this case, I return my superclass. Yeah, so what's the point here is, again, I declared the returning type as my superclass. However, for these functions, I mean, this is the function which returns the object of, yeah, remember, this calls the constructor, and it returns the object. So this particular function, it returns my subclass 1. this returns my subclass 2 object, and this returns my superclass object. So despite the fact that the type, the delegate type, but the delegate itself is the same for all these three objects, the returning type is different for them. Yeah, and this is because my superclass returns my superclass typed object, and remember that all the subclass typed objects, they are also typed as the superclass. And so basically here we do the upcasting in all these three cases. Do we have any questions about this? And yeah, by the way, so I guess we never used this before. So for the lambda expressions, if we don't have any arguments to pass, so like we previously remember that we pass x, y, or something like that, and in this particular case we have no arguments to pass. Yeah, so if you have the case when you have no arguments to pass, then you simply use this rounded brackets, means that no arguments to pass. So it means there is no arguments to pass. Yeah. So this is the point here. So is this clear? Do you have any questions? Okay, so this is just information for information that we can do it. Yeah. So and if we have constant variance, so let's say we have delegate void, and so we have the void here. Then we have the void which does something, and then we pass this void. Yeah, so basically in this case there is nothing really interesting. We simply have the delegate, and then we pass the no. So here we have, yeah, sorry, I haven't realized. Yeah, so here we have the subclass, and then we pass the superclass. Yeah, so in this particular case, this is, I would say, more tricky case, and I'm not really sure if this would work in all the cases. So let's say I have the situation when I have my subclass delegate. So let's say the returning type would be my subclass 1, it would be my subclass, let's say sub1 delegate. Yeah. So in this particular case, if I try to create my subclass delegate, we get, let's say my sub1 delegate or something like that. And I try to, let's say I try to cast my superclass, and in this particular case it will not work because the returning type is different. So in this case, if I want to pass, maybe let's just use it this way. I have the void here and I have the argument. So the thing here is, so as in this example, the delegate wants the superclass, but we actually pass the subclass. Oh, sorry, delegate wants the subclass, but we pass the superclass. So in this case, the countervariance does not really work. So in this case, I have the argument. Let's say the argument would be so in this case I use delegate. The argument type. Let's say I try to pass the argument as my superclass. Let's say I do something here. Yeah, maybe I print something. So we have this print. So print arguments. Oh no, sorry. Yeah, of course. Need to write it this way. So the thing here is that the parameter type is not match. Yeah, so I have the superclass pass here, and it is not acceptable. Yeah, so yeah, basically in this case it's same as for the casting. Yeah, upcasting will always work, but downcasting triggers some problems. Yes, so in this case, counter variance is not really what we can do. Yeah, so the things to remember: the same parameter value is passed to all methods in the delegates invocation list. And so the parameter type should be the same. If the invocation list is empty and you invoke the delegate, it will cause a runtime error. Yeah, like if there is no, same as for the objects, you use null object which is null. In this case, it will obviously trigger null reference exception. If you want to remove a method from an empty delegate, it's not an error. And to remove a method does not exist in the invocation list. Okay, we'll maybe talk about the invocation list itself. That's mostly related to the events, so we will talk about them next. But you may notice that delegates are quite similar to events or to the interfaces, though there are some differences. Let's maybe go through all of them. So for the delegates, you can call them when a single method is being called. Yeah, so basically, yeah, I mean the delegates itself, they are so interfaces. The interface is the type itself. So the type which, I mean, we can also move the interfaces from one place to another, but they should be assigned to the objects. But the delegates themselves, they are assigned to the methods. Yeah, under the interfaces, we can transport the object from one place into another. Using the delegates, we can not only, but we can transport the methods instead. Yeah. So yeah, it's mostly about event type return. So we discussed them. We have the callback function. Yeah, callbacks. Yeah, maybe short about the callbacks in programming. In programming, in lots of different programming environments, callbacks are the functions. Yeah, these are the functions, the pieces of code, yeah, the methods which are executed usually on some events. Yeah, so simple example would be like you edited some kind of document, then when the document is saved in the application or anywhere else, when the document is saved, then there may be the callback on save event triggered. Yeah, so you do some actions, then the callback is called. Yeah. So for the callbacks, we can define different time to be executed. Like it can be executed when you open the document, when you close the document, when you maybe change some value. So usually when we apply the events on some kind of changes, on some kind of actions done by user or by system, if it's done by system, then usually there are the callbacks called instead. There are the callbacks called in such cases. Yeah. And the interfaces themselves are mostly used for types, not mostly, but they use for types. So using them, we can declare the pattern for the classes. And yeah, the classes. Yeah, so maybe some simple differences. Interfaces have only public members. Delegates can be declared inside the class, and they can have any access modifier you want to use, public, protected, or private. And so we can declare them that way. Yeah, and then in general we can then talk about. So this would be the next. This is the next topic, and this is the topic about the events. So for the events, we mostly talk about publish, subscribe. Yeah, we'll talk about the events, but yeah. So first we need to talk about publish, subscribe return. So we have the publisher, and the publisher determines when an event is raised. The subscriber determines what action is taken in response to the event. So again, simple example: we press the button, that is returned by publisher. Button is pressed, and then the subscriber determines what are the actions needed to be done when the user, let's say, presses the button. As I just said, and as the simple example would be, sure, let's maybe go to some kind of website, maybe take random website like apple.com. So we see we have the buttons, and if I go to the inspect elements, now we have the, let's say, the button here, button, but okay, maybe that's not really okay. This is the button. So I have the button here, and we have event listeners. Yeah, so basically here we can see the elements. Then we have the listeners. Again, I just take this as a simple example for you to understand that. Again, let's say we have the button here, the button. Then we have, okay, there is the reference, but yeah, we have the listeners, event listeners, what are assigned to this particular button. So it means that when I click, then this event is executed, this one, and so on. Yeah, so basically all these events, oh no, sorry, hold on. No, yeah, this is correct. Then these events are assigned to, I'm not sure, to this button. Yeah, so then for, yeah, basically these are the events which are assigned to all of the elements, and then there are some particular events, yeah, like this event. So this is the JavaScript function, if I'm not mistaken. Yeah, so there's the JavaScript function inside, which is then triggered on the button press. Yeah, so basically, yeah, we have the button and we have the event assigned on this. I mean the button. I mean in this case, in this particular case, this button. It can also be some kind of events like the user types the text. So let's say that the user types the text, then let's say the text matches one specific pattern, then the background project, the history backgrounds where also front-end event is triggered and does some, I guess. So basically we can schedule event at any subscribe the event on any possible action, like user presses this button, or user types something, or user maybe user waits also for some kind of minute or two. Yeah, so this is also the event. So basically we need to understand what do the events mean from the programming perspective. And here we talk about the events from the user perspective. Basically the question is, what does the user do? User types, user basically do any action. User can do any possible actions, and these actions can be then handled. I mean, we can subscribe some events on the actions, and then they are published. Yeah, it can also have multiple subscribers, so it means that on one particular event we can have multiple actions, like I press the button, then there is one or another logic executed. And they can also have no subscribers and are never called, so this is also possible. Yeah, but usually the events are returned in runtime, so it means that again, there's object-oriented programming used. Yeah, so like we have them. the application, then there is some kind of program which prepares this application, which loads this application. So during the load, this information can be taken from somewhere. I mean the information about what kind of events should be assigned, and then these events are assigned on the loading of the application. Then, okay. Yeah, events are typically used to signal user actions such as button clicks or menu selections on graphic user interfaces. But I mean, in practice, it can be anything. Also, it can be not only about the user actions. It can also be on the system actions. So let's say that so from my experience, it's typically like we have some kind of collections. Yeah, collections, they may store some kind of user information or basically, let's say, any data. So maybe, so let's say we have the web shop, which, and then we have some kind of inside the program, we have the collection stored, which stores, let's say, the products. Okay? Collection of products. And then let's say we have such event. We say that the new element is added to the collection. Well, this is the element, not add, but simply, let's say collection is changed. Yeah, so add one element or remove it or do some other things. So then the question may be, not the question, but then let's say I have one specific action, what I need to do when the element is added to the collection. Maybe I need to register this, I need to place it in the log, or I need to maybe notify anyone that the element is added to the collection. Yeah, so it can also be done by the system. System sees that collection is changed, the program sees that collection is changed, then there is some kind of event triggered after that. Yeah. So also not only user actions, but system actions can also be handled. That maybe something is changed, or maybe something goes wrong, or anything else. Yeah, it can be determined by the system and then used. Also, it can use the synchronous threads, but this would be the later topic. Okay. And yeah, so here we talk about event handlers. So if we have the functions subscribed to the events, they are called as event handlers. So it means that they handle the event, like we have some kind of action done, then event handler is called. And so we have publisher, have the event, and then when the event is done, then the event handler is basically, it handles the event and it does some technical action. So event can be the technical action or maybe non-technical action, like the user does something, but the event handler is technical action, which is the code, the function executed after that. After the event occurred. And yeah, so event handler is just a normal method, just the usual logic which does something. So yeah, then we finally go to the events. So this is the way for a class to provide notifications to the client of that class when some interesting thing happens to the object. I mean, it can be anything, like object is changed, some value is changed, and we may register the event in this case. Can even provide a general useful way for objects to signal state changes that may be useful for the clients of that object. Yeah, maybe again some change history or something similar. Events are important building block for creating class that can be reused in a large number of different programs. And yeah, also events in C# are declared using delegates. So this is where we use delegates. And this is actually what is needed, because you see that we have the event and we have event handler. But the thing is that the event handler is the method. So we simply need to assign the method to the event. But again, remember, I said we have the case when one event, it may have, like in this case here, you see, one event, it may have multiple subscribers, multiple event handler. So it means that when I press the user, for example, presses the button, then maybe the method A executes, method B, method C, and so on and so on. So there can be multiple actions executed on one event, on one technical event. Yeah, and in C#, event satisfier delegates. An event is a way for a class to allow clients to give delegates to methods that should be called when the event occurs. Yeah, so simply we call the method, not we, but the program calls the method. So yeah, then the question is how the events are implemented. So first of all, we declare the delegate for the event, then we create the class event arguments to encapsulate the information about the event. So basically, we store the we store the delegates under event argument class. Yeah, so like easily we can say that this would be the case when we have the simply have the collection, some kind of collection which stores the delegates, and then all these delegates are executed once the event occurred. Yeah, once we say please trigger all these events. Please trigger all these delegates. So then create the class that will raise the event. And so this class should have an event which will have registered clients and a method to notify the registered clients. Then we need to create a client class. And so this will be the class which matches the signature of the delegate and will receive the events, and then it will be authorized for the call. But so let's maybe just make it more interesting. Let's write the code directly down. A moment. Yeah, actually there is built-in element event handler in C#. Moment. Okay. So let's declare the public event for the private event. This matter. So private event will be event handler. So this is also the delegate itself. So here I pass event arguments. And then I have, let's say I have the method, which, oh yeah, by the way, one thing I forgot that, let's check, okay, so, okay, I want to explain this. Yeah, so first of all, for this one, we can call the method which publishes the events. Moment. Moments. Oh, okay. That should be fine. Yeah, just was a bit confused here. Yeah, so let's then run it here. So the thing is that here I can call the events. Oh yeah, use the uppercase. Then I use this event. So this would be the handler, and then I pass. So it asks the sender. Yeah, so remember that for event handlers we have the sender, and so then we should have the information from where do we want to share the information, and then we pass the arguments. So, and yeah, so this is regarding the arguments. And yeah, then let's say I have the method which say, yeah, so let's say button is pressed maybe. So I create the which say button pressed, or maybe, yeah, usually the methods are called on button pressed maybe. Pressed. So then we can say that button is pressed. Here maybe I can use again print, remember we declare this delegate, and then I say button is pressed. So I have this method, and then yeah, of course I can check if yeah. So by the way, in C# versions we have this option to check if the event is null or not. Yeah, so a question mark. Oh, hold on. Okay, maybe let's just simply use all the versions. So that would be if this event is not null. I think that's just string, but okay, it won't be null. It won't be null. I will create them. Yeah, I will create them and moment. And so this was a little bit confusing. Put chip on thing. So something that's confused here, so let me just apply, I think. Yes, I comment. Yeah, I mean, of course, we can then write the subscriber method or the class or the method. So let's say that would be, let's use private subscribe. Private void, yeah, that would be subscribe. So then I publisher here, oh no, sorry, not publisher. And yeah, let's say I have the event here. So that would be the event, handler, event. And then let's say I add, oh no, so in this case I already have it. So then I set this event, and then I can add a new handler. So let's say that would be on button pressed. event. Oh yeah, of course, yeah, button pressed, and here I get the sender. Yeah, of course, the type should match. Because because I can have event arguments and I can have type. Yeah, so in this particular case, this would work. Okay. So. I don't think I'm confused in this example. In this example, the event was not initialized. One moment, I'm a little bit. Yeah, so in this case it should, yeah, so in this case let me trigger the, maybe I'll not, I will wait not check this one. But yeah, so the thing is that I can say register subscribe, yeah, okay, subscribe moment, subscribe methods. In this particular case, it should trigger me the no pointer, sorry, no reference exception, because I have not initialized the event. Yeah, so, oh no, hold on. Okay, so it worked. Yeah, because I was a little bit confused. Why the event is not initialized. But okay. It looks like we don't need to initialize, because I was pretty sure. Yeah, because this was a little bit confused. Hold on. On the other hand, we maybe not need it. Yeah, okay, events are a little bit different. But okay, so we see that we have subscribe one button press. So let's say maybe I, in theory I can also subscribe. I can pass the method I want to subscribe. So in this case, I can I can maybe use the delegate, or I think one moment. I think I can use the already existing one. But okay, maybe I'll just not check. We can declare also our own delegate. Public. Let's say what to be private delegate, maybe private delegate. Let's say event. Wait, let's call it event delegate. So that would be the what? The what? And then I pass the object, and I pass the event element. Okay, so this will be the event delegate. And then let's say here I pass the event delegate this way, and then I subscribe this event. So I have one event, and let's say I subscribe and I pass and it's not it was few. One moment. The types are the same. So it was this thing. Double void. Okay, system handler. That's strange because I can directly pass one button pressed, but I cannot directly pass delegate, which is similar. Okay, so in this case I can okay, then I can then try to cast this way. And I can cast it. Let's try to cast it here. Or it does not want to convert. Okay, it does not want to convert. Okay. Okay, so moment. I had another example to check. There's another example. 1 moment. No, hold on. Moments. Okay, now in this particular case, okay, maybe just to make it easier, I will not call this. Yeah, so maybe I will. At this point, I don't need sender and receiver, or maybe no. Let's keep them. Sorry for just putting the close, but yeah. So let's then keep them as is. So in this case, I will then maybe not declare even delegate. Separate delegates, but I will pass them this function on button pressed. And yeah, okay, this will work out. Sorry for a little bit confusing, but okay, that's better now. Yeah, so I pass the function I want to pass to this method. So, and the thing is that I can pass any function I want. So let's say this is button present. So let's say this would be then, let's say on let's say walk change, or maybe simply on change here. So then I can say something is changed. So let's put something is changed, and I can also subscribe this event. This subscribe. This simply on change. Yeah. So this is the concept. Yeah, maybe this is just a rough example. The practical task will seem maybe more relevant one, but yeah. So the point is but the point is that at some point we collect these subscriptions, and then we trigger the event. Okay? Then we trigger the event, so it is triggered at this point. Event is triggered here. Yeah, so basically we have the sender, so this is the class, and then the arguments passed. So these are the arguments which can be passed to the method. Yeah, in this case maybe I will not go deep here, but for the event arguments. So the event arguments. Moment. Okay, so I'm not sure why there's no methods here. Okay, maybe about the terms later, but yeah, the point here is again, here it stays the same. We subscribe let's say one element, one function, another function, then another function, and then when the event is triggered, so here we trigger the event, these functions are called. Okay, so all these functions are executed. Okay? And again, the sender means which particular class sends this data. Yeah, because we may have some, let's say, the elements or the methods used from this particular object, and then we can use these elements and methods for our logic then. Okay, so this is the point here. Do you have the questions about this particular point? Okay, maybe this looks a little bit confusing, but the concept is the same. As I just said, we subscribe. I mean, the events are registered one by one. Okay, so let's see that one event is added, then another event is added. So there can be many different, not even, sorry, event handlers. Yeah, event handlers added, another function added, and at the end, all these functions, when the event is triggered, all these functions are executed. Yeah. So this is the key point concept. How it can be implemented in different ways, but we set the handlers and we raise the event at the end. Okay. So this is the point here. So here's the similar example, just taken from here, and yeah, so we can also get new event arguments, but maybe I'll talk about event arguments in terms of, yeah, we can also pass some arguments to the events if needed, but in this particular case, maybe I'll not use them. So let's take a look on one example. So we have the delegate which is used as the event handler. So then in this case, we have the variables, that's fine. We have the constructor of the class. We have also some elements there. And then we have another class which detects the element detector. So then we have some voids which does some logic, and yeah, then we create the arguments element, and then yeah, we pass it to on event, on event. Yeah, an event. So this is the method. Yeah, so when the event is notified, yeah, so at this particular point, something is triggered, then then the event is triggered. Yeah. So yeah, basically the concept is still the same. Listeners are, sorry, not these listeners. Yeah, listeners are added. So in this particular case, for the event. So here's the event declared that. It is declared. Okay, here it is declared. Just a little bit strange way, but yeah. So here the event is declared, and the event is raised. Yeah, event is we basically execute all the listeners assigned here. Maybe the structure here looks strange, but yeah. So basically at this point, here we add the handler. We register the handler. So the handlers can be registered at any point and simply added to them to the element. And the thing is, if we don't trigger the event, you see that these methods won't be executed. So this is the point. If event occurred, then methods are executed. If the event is not occurred, then these methods are not executed. So this is this is the point for the events. Do you have any questions? Okay. Yeah, the event uses public field. You can still customize additional and removal of subscribers. So it's very important to put a lock around adding and removing subscribers to make sure that the operation is thread safe. Yeah, so this is about the threads. We'll talk maybe next week, most likely, about the threads. But yeah, so using the locks, it's possible to yeah, it's possible to lock them to make the thread safe. But this is about the threads. We'll maybe talk then most likely next week. Also, as yeah, so these are basically the additions. We can lock. We can also make the asynchronous call. So asynchronous calls. This is yeah. So this is the way how we can call the delegates in asynchronous way. Yeah, because sometimes it's also maybe important. Like again, in this case, you see that we subscribed. No, so we add several subscribes to the event, and then we execute the scene. But the thing is that so again we execute the actions. So let's say we execute one action, then we execute another action. The thing is the question may be how they are normally executed, like in what sequence, because the sequence is also important. In this case, we see that they are executed in the way that they are added. Yeah, so first of all, I have the sorry. Yeah, so this particular case, you see that they are triggered simply one by one. And so the first method I added is the button is pressed, yeah, which prints that the button is pressed. And the second one shows that something is changed. Yeah? So basically, one by one. Sometimes it can also be necessary to change the sequence, to align the sequence, to maybe sometimes it's also important to execute the element in parallel, so we can use multiple threads. But this is maybe a different topic. And yeah, so also about the asynchronous. Maybe I will not really talk about advanced asynchronous method calls. So this may be more about yeah, I think we can more about threads. You know, so maybe I'll not talk about asynchronous call, but so just yeah, apart from threads and asynchronous, do you have questions about the events? And so the concept is, let's say, quite simple. We have the event. Yeah, so in this particular case, I define the event as event handler. So in theory, I can make it say more simple. I can create, yeah, we need the pattern. So, but let's say I have a simple pattern. So that would be private or public. Maybe in this case, let's use public. And the pattern, let's say, would be say the pattern would be private here. The pattern would be, let's say, the void and let's say that would be simply my event or something like that. Yeah, so my event delegate, or maybe it would simply be my event. Public delegate. Public delegate. And then I create the private event. Private event. My events. Yeah. So it's my event delegate. Then this will also be. Oh, sorry. My event delegate. My events. Yeah. Vice versa. So in this particular case, it means that this event will accept all my event delegates. So, and let's say here I can do some actions. So let's say that will be private void, do something. So let's say print this method does something, and then I say create another method, for example, just to make it different. Let's say this one does something too, and then I print this method also does something. So, and in this particular case, I can again create event, or maybe I can create a separate method, or I can just simply access my event directly. I add then this do something, and so it matches the pattern, so I can assign it. And then I can also do same for my event, and then I do something again. Yeah, and at the end I can execute my event. And then it will execute these two functions. Yeah. So you see that these methods are executed. Yeah, so at this point I just wanted to show that the pattern is not important. I can define my own pattern, what I want. In this case, I define that pattern on the function would be just a simple, is this pattern would be this one, and my event delegate, and the pattern is simple void without any parameters. Yeah, so it means that I cannot assign the function which does not match this pattern. Yeah, so I cannot assign this function this method. Oh, hold on. Yeah, so it cannot be done. Is the method does not match the pattern. Yeah, so it must match the pattern, so we can add then this particular event. So okay, do you have any questions about this?
Yeah, hello, I have a question.
Yeah.
I wanted to understand, event basically we can use when something is happening, like for example, some kind of, if we are talking about web, then some kind of action from the user is
Yes.
asked, for example, button pressed. Can you maybe explain where is this border where we can't use events anymore, where they are not used?
I mean, they are used when we want to handle some actions. I mean, want to register some actions. For example, again, the button press would be a simple example. Another example would be that the program. So, for example, let's say that. Yeah. Also, it can be technical. So let's say I have the collection private. So I use the collections. The system collections, and then yeah, let's say I define the collection. My collection here going to be. So one moment. Yeah, so let me be the list, for example. The list string, for example, yeah, just a simple collection. Then let's say I have, for example, I have duplicated collection. So copy, yeah, so maybe duplicate. duplicate collection, duplicate list maybe. And okay, so then yeah, so let's, yeah, we can create maybe these lists directly. So that we have type here, and okay, yeah, basically these lists are, basically they will duplicate each other. So, and let's say we have the event public. Yeah, maybe at this point I will use the same. Oh no, hold on, I will. Let me quickly think. Yeah, so then the events be events on collection changed, and yeah, so that would be, and here we'll add the function. So the function would be, I will maybe use the same my delegate. Oh, hold on, was it my delegate? A moment, what did I just used? I use my event delegate. Okay, so maybe I use that the same here. Okay, yeah, and then this will be on collection changed. So for example, yeah, so initially I can subscribe, and let's say public public event, no, sorry, not event, that would be the function, public void, let's say copy paste collection elements. So this is just a dummy example, but we have some copy paste collection elements. So, and yeah, so from here, let's say that I have duplicated list, and then should be list, but sorry, this duplicated list, and so maybe I say I clear the elements from here, and so then I add not the range, but I will add, I can only add one item. Okay, then what we can do, we can then do for each, then I access, so this is again just a dummy example, but for you to understand, or sorry, vice versa, elements in this list, and then I can add the element to the duplicated collection. Yeah, so, and in this particular case, let's say that I have the method like public void say add string to collection, or sorry, maybe add element. Yeah, I mean just simple add element. Say the string elements, and I will add it to my collection. This list, and I will add the elements. So, and let's say maybe I remove last element or something like that. Last element. So, and then I will twist, and I will move at the last position. Yeah. So counts -1. Okay. So and what do? I have event on change. So now on collection change, right? Yeah, on collection change. More precise, that would be on list change. Okay, so just for you to understand, and then we add the elements. Let's say we have this copy paste. Yeah, so we have this element, copy paste element. So, and then let's say I have the method void change. Maybe do some changes. Yeah, do some actions on collection. So and from here, let's say I maybe add the element. So say my element or something like that. And then I can also maybe remove the element or do something like this. Right, yeah, of course I need the last element. And so maybe let's add some elements there. Okay. So then I do some actions. So let's say we simply do some actions on the collections. And so it doesn't matter which actions they are. And so at the end, I can trigger the events on collection change. Yeah. So at this particular point, when we trigger this event, it will trigger all the necessary actions which should be handled by the program on collection changed. Yeah, so basically we touch the collection, all these specific methods will be executed. Yeah, so we register these methods, then these are executed. Why? Because there may be some alignment needed to the data. For example, as maybe we can take a look on this next time. So, for example, when the collection should also be sent to the database, update inserted to the database. So in this particular case, we may do the changes, and one of the potential actions would be that handlers would be that we simply put the elements to the database at some point. Yeah. So we put the elements to the database, we notify user, maybe we print something. Yeah. So it can be all the actions what needed to be done when the, let's say, collection is changed. Yeah. Add to the database, maybe copy paste the data, change the data, basically do anything needed when the collection is changed. Yeah, we can then trigger a particular element. Yeah, so is it more clear, or you need anything else here?
Okay, thank you. It's more clear.
Yeah, so okay. Are there any other questions? Okay. Then I think we gone through all the key points about the events and delegates I actually wanted to discuss today. Maybe do you have any other questions related to delegates or events or any other topics? Maybe I think there is unclear for you. Okay, then if no, okay, then I think also for today, then we covered all the necessary topics we wanted to cover. So, okay, then I think we then can finish also earlier today, since we covered all necessary topics. And then we have the session on Saturday, and okay, let's see, maybe I will also prepare some materials, maybe also about a little bit of web programming, so we can have at least the knowledge on. Oh no, maybe maybe on Saturday we will mostly then work with the files. Yes, I wanted to cover the working with the files topic, so we can discuss this on Saturday, and also um, I shared the last activity 9. So this is about the events and delegates. We also take a look on this on Saturday, but this would be the practical task for you, the individual task for you. Okay, so, but yeah, this we'll then discuss on Saturday. Okay, so if there are no any questions, then I think we can finish today. If you have any other related questions, you can, as usual, you can reach me, and then meet you all on Saturday. Okay, then thank you very much, and have a nice evening, have a nice Friday.
Thank you.
Have a nice
Bye
evening.
bye.
Thank you.
Bye.
Goodbye.
Bye.